Hey everyone, and welcome to another episode of the Digital Dentistry Decoded podcast, the podcast where we keep you up to date and in the know with all things digital dentistry. Today we have a special guest, someone from a company that basically invented horizontal scan bodies. They did this before it was cool, and we are seeing a wave of these sort of devices come on the market. This is Julio Rojas from Osteon Medical. Welcome, Julio.
Ahmad, thank you very much for the invitation, man.
My absolute pleasure, my friend. Look, it's we've known each other for a few years now, and it's always a pleasure to discuss and really watch how the industry has changed.
Yeah, definitely. No, absolutely. And happy to chat. Thank you for the invitation.
No worries. Look, we may as well just get into it. Look, Julio, for those who may not know what Osteon Medical is, what they do, and also your role there, and give us a bit of history of your background, how the company started and everything.
Absolutely. So Osteon Medical started around 2009, around 15, 16 years ago, more or less. We actually were conceived as a startup. It's basically the brainchild of Michael Tuckman, our founder. He is a dental technician that worked with many well-renowned dental technicians, and he helped a lot of labs around Australia. At some point, he decided that what he was doing on the bench, it was probably possible to automate. So he decided to go back to university, start a mechanical engineering degree, and through that journey, he met a few of us. So we started as a specialized milling center from the university. We were able to jump and establish ourselves as a player in the market within the milling centers. And he put a few of us together. He invited us to be part of the journey, and yeah, that's how we started. Just a kind of a solution provider for all dental professionals.
That's pretty cool, man. So you must have been one of the first employees of this company, let's say, or almost like one of the founders, almost.
Yeah, I was employee number 2. He told me that he needed an engineer to help him out, and at some point, and I thought that the idea that he was getting off the ground, it was great. I was doing my master's in engineering at the same university, so I think that it was a great opportunity to kind of understand what he was, planning long term and be part of the journey for sure.
And the rest is history, eh? So like a lot has happened since those days. So you guys started off as a milling center. Talk to us about how you went from that to creating the Nexus iOS system. And for those who don't know, this is not like some marketing thing. They were the first horizontal scan body. And they kind of, a lot of the modern ones now look very similar to it. So that's kind of interesting. Please talk us through it.
Yeah, so obviously kind of the DNA of Osteon have always been innovation. And I think Michael have empowered or embraced, new technologies, and always allow us to kind of be on the lookout of what was new and what was possible with the technology at that point that it was available. So that's how Nexus iOS was born. Was part of trying to address a problem that we were seeing in the market, and a trend that it was actually at that point really early days of moving towards the digital world for full arch restorations. There were not many options at that point, and we were trying to kind of take advantage of like intraoral technology, how accurate some of these intraoral scanners were getting, and how we were able to kind of maintain that accuracy that it was being claimed at that point for full arches. We knew that obviously the technology was improving, and we wanted to make sure that we didn't really need any extra hardware to try to acquire the data. It was only using the accurate intraoral scanners and what we ended up presenting in the market as the Nexus iOS kit.
And so what exactly, talk us back. What was the problem? Some people are just getting into digital dentistry now and they don't know the troubles and issues, the pains that people had. So talk us through it. What was the issues with full arch workflows?
Yeah, absolutely. As I mentioned at the beginning, originally, conceived as a milling center, all the work that we were doing, it was analog work. So we obviously got the models, and the reason why we were able to establish ourselves in the market, it was because we figured out a way to guarantee that every single model that we receive, we're able to send out a passive fitting bar. So we knew a kind of the level of accuracy that we were aiming and we needed to get that passive fit on a model. What we were trying to do is replicate that, through intraoral technology, like directly getting the information from the patient's mouth and being able to replicate that into a passive fitting prosthesis. The challenge was obviously convincing the market and the clinicians that that was possible. Until that point, kind of the only alternative in the market for digital was photogrammetry, and it was kind of priced out for many, many clinics. So we wanted to make sure that there was a possibility for clinicians without investing, in a technology that you don't really know if it's going to change tomorrow, and taking advantage of intraoral scanning, which was kind of developing really well. How we can guarantee that we can take that information from the patient's mouth and make a full digital workflow, a passive full arch prosthesis. The technology, obviously, for single units, small bridges, at that point, it was already proven and accurate enough, but full arches was the challenge for sure.
What's that level of accuracy? I mean, there's a lot of talk all around the industry of what's good enough these days. But what was the level of accuracy you guys were going for when you say we needed, we were aiming for this?
Yeah, so we developed all these range. We were aiming between 10, 20 microns. That's what we were aiming. Like on models, we use a contact inspection machine to try to give us the accuracy when we actually got models. So that's how we were able to get a passive prosthesis. The objective was how to try to get that same level from intraoral data, which obviously at that point was not really possible. There was a lot of information, a few studies that we were able to come across, and our internal testing that showed us that it wasn't really possible to get that level of accuracy without actually investing in external hardware or different technologies. So that was kind of the main thing. And another thing, we wanted to make sure that we could prove that without impressions, we actually could get this process going. Like, just make sure that it was a full digital workflow. And that was kind of our main objective for sure.
You guys must have been way ahead of the time, man. Kudos to you guys. I mean, what a journey. You were doing something, I'm sure you got a lot of heat from the entire industry.
Yeah, the pushback was substantial. You try to convince clinicians that have been doing a process for many, many years that here I come with a kit, and if you invest in this intraoral scanner with this kit, I can take digital impressions directly from the patient's mouth. But not just that, I can actually make a passive sitting prosthesis with no models, no verification jigs. So it was a pretty tough journey at the beginning for sure. We got a lot of pushback. The good thing is that we were able to convince those first adopters pretty easily, because as soon as you convince them to do a case and then they start seeing the results, the rest is history. Like, they definitely have embraced it for sure.
And it's funny how now the market has totally opened up to this idea. Now it's totally accepted.
Yeah,
it's
exactly.
Crazy. You guys almost laid the foundations of opening this up for everyone.
Yeah, the horizontal flags, as you can see now, one is being launched every week. Originally, when we first presented into the market, there was many people that told us that we were totally wrong and it was not going to work. There was a lot of negativity. I think that intraoral technology wasn't at the level before that could have given us probably an accurate output. The good thing is that we were able to be at the right time with the technology. Like, intraoral scanners actually got to a point that gave us the level of accuracy that we needed to get to kind of join it with the scan gauges kit and be able to develop that. So I think that it was also a great outcome there, because we have been following intraoral technology since it was available. And we basically developed a strategy of how to test intraoral scanners and how to guarantee that the intraoral scanner is accurate enough to be able to, using our kit, deliver the output that we were aiming. Before that, none of the scanners that we tested were actually giving us the accurate representation on those implant positions. But at that point, everything kind of got to a place. We were able to develop this kit and get intraoral scanners that were at that accuracy level, and we were able to take it from there.
And that's super interesting. I mean, even now with these modern intraoral scanners, I mean, there's a few companies that say they don't need any extra kits or photogrammetry or horizontal scan bodies, but most of them still to this day, with the stitching errors for full arch implants, you can't really use standard vertical scan bodies, right?
Yeah, I mean, absolutely. We have maintained that testing discipline. We try to keep up to date with any new intraoral scanner in the market, just to guarantee and confirm that the accuracy is still there. We have seen the accuracy kind of improve slowly, and definitely seeing companies that have invested into new technologies and strategies that definitely improve the acquisition of data. But at the end of the day, exactly as you describe it, intraoral technology has certain limitations because the field of view is obviously limited. The images that you get are all needed within the software. And a lot of articles show that that needing process is what actually start kind of affecting the discrepancy, especially on full arches. So the horizontal scan abutments approach solved that. Bridging the gap between, the implant locations is proven that actually improve the accuracy of the acquisition that you're trying to record for sure.
And so before all of this, I mean, how were people doing it? Just verification jigs. That was the way, or a
Verification jig.
photogrammetry.
Yeah. And I think that you probably will see in a few of the competitors that they still recommend that verification jig because it's not just the horizontal flag. In our system, there's a lot of things behind it that they add up to achieve that level of accuracy. But beforehand, yes, verification jig and confirming that impression was taken probably in the best possible way. There was a lot of limitations with angle implant placement and things like that, that impressions or models every now and then show difficulty or misfits issues. As I mentioned, we guarantee that the bars will fit into the model, but there's a different thing to guarantee that it's going to fit in the mouth. So aiming to be able to work directly from the information that you gather from the patient's mouth and being able to reduce to the minimum any possible sources of error that will deviate that accuracy and being able to manufacture something, basically give that guarantee that you are trying as close as possible to what was originally recorded.
It's amazing, man. What a history. So what was the turning point when you guys realized that you were onto something special with this
Yeah.
system? When was it that you were like, okay, we're onto something?
Yeah. So look, Michael have always, as I mentioned, kind of allow us to embrace technology and pursue different ideas and different avenues. And he always proposed new strategies and trying to be ahead of the curve. So I think that it was a proposal that came and an idea that he put to the table, and he built kind of a group of mix of engineers and dental technicians, four of us that, led by him, started pursuing this avenue. He knew that the intraoral scanning was getting obviously better and better, and we wanted to take advantage of that without having to invest in any extra hardware or anything like that. We started working on it. I read a lot of articles available kind of basically proving that linking the distance between implants improved the accuracy. So we wanted to obviously take it to the next level. We knew what we were aiming in regards to accuracy. So how we were able to guarantee that. So we started designing these flags, these horizontal flags. We went through many iterations. I think that more than 30 different designs, different strategies. And it's funny how we see kind of the competitors these days, because I can see some of our earlier designs that we basically disregarded for one reason or another. And slowly, everyone kind of is moving to the same style, the same design. You see things like the taper design. The idea with the taper design was that you as a user, you didn't really have to tilt around the intraoral scanner too much just to try to acquire the data. So something that you do or you face with a vertical scan abutment is that you have to kind of rotate it around to try to get all the information. We wanted to address that since the beginning for the full arches. And features like the cutout of around the cylinder, there is intraoral scanners that if you don't have that foreign feature connected to the tissue, will delete the item straight away. So that's why we added that cutout on the cylinder area. The smart features on the top, to differentiate every single one of the kits, different cuff heights, because the multi-unit abutments can be in different heights. So you need to give the clinician options to be able to kind of arrange them and close the gap. So all these things that we tested and we proved and we kind of applied to this design, it took us obviously a substantial amount of time, but at the end we proved that it was possible.
So you guys released your first horizontal scan body kit or horizontal scan flag kit, the Nexus iOS system, in 2020. Is that correct?
Yeah. It was a little bit unfortunate because it was right through COVID. So actually, it was a little bit of a history because we were ready to launch in the 2020 ADX, Australian Dental Expo. We took our team, we were ready to show the world that we have actually been able to solve this problem. The day that we set up and we were going to launch and show everyone, the conference was closed, canceled, and we started dealing with all these, obviously, situation that everyone had to
Painful.
face. So it was a little bit disheartening, but yeah, we had to learn real fast to become really good at doing this. I'll be able to present remotely, experts using Zoom, Google Meets, and everything, because we wanted to get the word out. But it was a challenge. It was a challenge to convince through a screen to someone in a different place in Australia or overseas that we had this system that if you fully digitally embrace it, you were able to kind of get these full art restorations with no impressions. It was a very difficult challenge that we had to learn to overcome.
It's incredible, man. And so, like, we've only really seen all these other types of scan bodies come out around the past 12 months, maybe. So, really, you guys had like a 4 to 5 year lead on the entire industry on this technology.
Yeah, I was expecting some of these similar systems probably a little bit earlier. It have taken a while. Obviously, we hold the patent for the horizontal scan abutments, but we knew that it was coming. Obviously, everyone will try to, after a concept have been proven, you will definitely have people that follow it. And in a way, we feel validated because there was, as I mentioned before, there was a lot of people that did not believe that this was possible without having to use any other technology, just taking advantage of good intraoral scanners and a scan gauges kit. You were able to actually get the fit that you were after.
I'm sure the photogrammetry guys thought you guys were crazy.
Yes, definitely. Because at that point, the photogrammetry cameras probably were around 50 plus grand. So you coming with a kit, a small box, and just telling them, yeah, I can actually achieve that same accuracy with no verification jigs, just using your intraoral scanner is a challenge. So you have to prove it. The good thing is that our system, Nexus iOS is a full system. So the kit is just the first step, the acquisition of information. Then we have developed before that the kind of our prosthetic solutions, which is the Nexus prosthetics. And then we have a kind of the manufacturing of that. So all that to say that we are delivering a final prosthesis. So we needed to guarantee that acquisition, it was delivering results. It's not just the acquisition and I give you, some information and you figure it out. We were committed to deliver quality prosthesis and guaranteeing to that fit, to that passive fit. So we knew that we were able to prove that with the user and anyone that wanted to give it a go.
Fascinating, man. And so, when did you guys kind of realize that other people are moving in this sort of direction in the industry? Did you guys realize earlier that people were going to do this and basically copy the idea in some way or form?
Yeah, well, as I mentioned, we were always kind of on the lookout. This is not the first time that people have followed probably what we have done. As I mentioned, the Nexus prosthetics was something that we developed in around 2017. So it was the mill bar with a monolithic overlay. We first started testing that like 2015, and then by 2017, we figured out a way to do it digitally. We developed our own bar design software. We started working with Michael on that one since the university days. We actually have been able to patent a few things integrating angulated screw channel before angulated screw channel was even a thing into our digital design. So we know that every time that you actually present something to the market, people are going to follow if it's proven and people start embracing it and start using it. So yeah, probably a couple of years ago, we noticed that the market have already pivoted and then embrace our strategy, and there were many players and they will keep coming. I know that there's a lot of the big guys actually ready to present similar concepts, but I think that in our eyes we have proven that digital works. We were the first one that actually developed this full digital workflow and been able to show that it works, and have opened the door for a lot of people that are embracing it for sure.
I'm really curious, how does that make you feel though? I mean, when you guys started it, immense resistance, and I don't think, dentistry wasn't even that digitized back in 2020, let alone now where everyone accepts it's the gold standard and it's the standard of care. How do you guys feel as a company that all these new horizontal scan bodies are not just being released, but are almost capturing a lot more attention and noise?
Yeah, well, definitely it's a challenge to see that there's a lot of noise, because obviously there is a lot of good products out there, and we are happy that at the end of the day the clinician has options to choose. We don't want to just come here and say all the other systems are bad and we're the only ones there. We like people to test it and prove it, and I think that they can make their own informed decisions. Everyone is going to claim a lot of things on their website and say a lot of things, but at the end of the day, what is actually the level of acceptance and the quality that the clinician is after? We have a proposal on the table, and we know that our system, it will give you the accuracy, that it will guarantee that passive fit. There is a lot of options in the market, and if you're happy to embrace those and test those, we're happy for them to do a comparison and see the difference and see probably the final outcome, which is that final prosthesis fitting on a patient and changing someone's life.
I think one of the main challenges that you guys faced was obviously because as a business you need to have a business model around this. So you had the Nexus iOS kit, but that was originally, and I think the business model is changing a bit. We'll get into that, but originally it was tied to the milling center.
Yeah, it's just that we wanted to make sure that the discussion about the teeth was not affecting the accuracy of the data that we were able to maintain all the way to the definitive. So that's why we actually had to develop or introduce the Nexus prosthetics, because at the end of the day, no one really probably put that much attention to the fit if the teeth don't look acceptable. The aesthetics is not up to the standard that the clinician is after. So we needed to kind of, in a way, maintain control of the whole process, just to be able to prove that the beginning of the process, the acquisition of data, it was good enough so I can deliver you a final prosthesis with the setup, a monolithic setup. It was going to deliver the aesthetics that the doctor was after. So we had to create Nexus iOS. We couldn't just create the gauges and put it out there, because definitely we believe that if we would have done that, probably there would have been a lot of noise basically against the system itself. People trying to probably not milling or the outcome 100%, or not following the data, or not knowing how to actually use that data. So that's something that we had to embrace from the beginning, try to have control of the process from the acquisition to the design, to the manufacturing, and be able to prove to the clinicians that it was possible. Another thing that we had to obviously implement is the fact, and I think that is due to that remote difficulty that we faced at the beginning, it was the 2 scans. So any other systems basically ask you for 1 scan, and you use the library that have been created for that particular kit, and you get an output. We knew that we needed to guarantee that the data that we were working with, it was the most accurate representation of what was in the patient mouth. So that's what we put forward, these 2 scans strategy. So as soon as you get these 2 scans and you are able to corroborate that now with the software that we developed to use chairside, then you have kind of the peace of mind that those scans are accurate enough for us to be able to move forward with the case.
It's like a verification.
Yes, it's the Nexus Analyzer, which basically take those 2 scans and basically give you an output on the spot. So
for those who may be listening and don't really understand, it's basically like you take your edentulous scan, then you put these horizontal scan body kit or the horizontal scan bodies from the Nexus iOS system into the mouth, and then you scan basically from left to right and then right to left. So it's 2 separate scans, and then you can verify that it's accurate.
Yeah, exactly. And, all these things have a reason and a testing behind it. We did a lot of testing, as I mentioned, many iterations. The reason why we asked for the left to right and right to left scan is because we noticed that in many of the tests that we took, the start of the intraoral scan actually is the most accurate piece of the scan. And then slowly, along the arch, you start having discrepancies that accuracy start being affected. So actually getting 2 scans of the same arch and being able to, as we do, integrate it into one main file that we work from, allow us to kind of take the accuracy to a different level. And the other thing that probably we embraced before anyone else in the market, it was the unique DME files. Every single kit is unique. They have a unique library, and we basically had to figure out a way on how to, after every single scan gauge is manufactured, how to create a unique and very accurate library that it will fit that kit alone.
And now we're seeing all these sort of techniques and the likes of the IPG kit from Elite and a bunch of different kits that are open, like Scan Ladder and some other kits. And then we're also seeing not quite the same idea, like a titanium kind of scan body, but like with Apollo and using peak across the arch. It's kind of fascinating how it's changed, because I think with the Nexus iOS system, it was bridging the gaps around the arch, but with these other systems, it's like converging towards the middle. And I think
Yep.
that's been kind of a change in technology.
Yeah, 100%. Obviously, the scanning strategy kind of changes, but the aim is always the same. How do we, in a remote way, how we get the information kind of in the most accurate way from the patient's mouth? So all these new strategies, a new way to arrange the gauges and things like that, at the end of the day, they are using this horizontal approach, which it try to address the difficulties that you face when scanning full arches in the mouth. You see features like the taper approach in many of these scans. You see the lengths, different lengths in many of these systems. They are always trying to solve the same issue. At the end of the day, I think that the main objective is to look at the quality of the components that have been put in those kits, looking at how they fit within the multi-unit abutments that are being used, and just seeing the results, so seeing the outcome, see if you are happy with that accuracy that you're getting, if you're happy with that fit. As I mentioned, at the end of the day, the clinician is the ultimate judge, and they are the ones deciding if this system is suitable for me, if it's giving me the outcome that I want, is probably the right system for my practice.
Do you think this whole issue, as you call it, is solved? So, like, I mean, do you think the days of external photogrammetry kits are numbered? Do you think, as an industry, because a lot of people seem to think, a lot of the scanner companies are like, look, throughout the past 10 years of intraoral scanning, there was issue and we solved it, issue and we solved it, like monochrome scan, color scans, scanning bloody regions, deep tissue, I mean, deep preps, all of these sort of issues. And this has been a thing that's been bugging intraoral scanners for some time. And do you think now with these horizontal scan body systems, it's just solved, it's done?
Yeah, I think that is really, I see a world where doctors actually use different systems depending probably of each patient and what are the challenges within their practice, what people they got, what level of expertise is within their clinic. Obviously, photogrammetry has been around before us. And as you mentioned, there was a lot of challenges that they have been trying to solve through all this time. I think that what we did, obviously, it was putting an option on the table and say, look, if you don't want to invest in such a technology and you want something that probably you already own an intraoral scanner, there is an option here that it can give you better quality of the workflow, accurate results, and then you're able to take it from there. So, at the end of the day, the market is changing all the time and everything evolves and there is new systems and new options out there. I think that at the end of the day, we need to be open, and probably it's more about the choosing the best tool that suits the clinic and probably the efficiency within the clinic.
Do you think that best tool is traditional photogrammetry, though, with the crazy prices that they are? I don't know. I personally think it's gonna slowly die away. I don't really see a future where
Yeah. Well, look, I see, that intraoral technology is getting better and better. And I've seen kind of integration within the systems as well, the horizontal flags and intraoral technology. And I think that probably there's a world where, that's kind of moving in that direction, kind of integrating the best of both worlds and trying to get technology more accessible to people, like within a price range that can be accessible for everyone. And at the end of the day, we're all chasing the same thing, how to solve the problem of getting the best data from the patient's mouth, not having to take an impression, not having to take a verification. We're all aiming to solve the same problem. And I think that ultimately is a benefit for the patient, which is, for us, has been always the point forward, like how we make this better for the clinician, yes, but, to make sure that the appointments don't last as long, that you are able to do all this process in a more repeatable and consistent way.
Speaking of the data, because there's a lot of misconceptions, because if you ask clinicians a discrepancy of how many microns is sufficient or acceptable for a full arch restoration, you will get a range of different answers from 20 microns to 10 microns to 30 microns, 40 microns, 50 microns. I think we all accept anything over 100 is crazy, and you won't get a passive fit.
Yep.
But, when is good enough? When is good enough, should I say? And what is that level? I mean, you guys are chasing 10 to 20 microns. The elite, they're getting around 20, 30, maybe 40 microns. Depends on which paper you read. Some papers say lower, some papers say higher. And I feel like it kind of goes back to what you said. The clinicians seem to be happy. I mean, I've used the system and I've used your system, and they all seem to get good results. So for you, not just as a kind of as a company, but also just thinking about it from a clinician's point of view, what is that figure that's good enough for Falach?
Yeah, it's hard to put a specific number, obviously, because I think that we see it more as a range. I have found articles online that say that 100 microns is okay. Definitely, that's probably something that we will not allow to be manufactured here. Like, we will not accept a data that is showing such a level of discrepancy. But because we know that maybe you will manufacture something today and you won't gonna see any issues, but we know that over time there could be breakages on the overlays and things like that, and you put at risk the prosthesis. So as I mentioned at the beginning, we chase that 10 to 20 microns mark. I think there is a level of difficulty trying to guarantee that in the mouth you get a passive fit. You know what I mean? Because you cannot measure microns in the mouth. The X-ray give you millimeters, not microns. And so you actually have to do this bench testing, which is what we have done all this time, and make sure that you're within that range of 10 to 20, probably around the 30 microns mark, which is already within the tolerances of the manufacturing. Also, you have a reference. Sometimes we ourselves split the data in two. There's a difference between a radial kind of discrepancy and an axial discrepancy. It's not the same thing to actually have a big discrepancy on Z, which it will mean that definitely the prosthesis or the connection is not going to see it, that they have in it X and Y, which within certain tolerances, you will be able to see it on that multi-unit abutment. So I think that it needs to be kind of split in two, and the Z value is very important. That's kind of the one that guarantees that there's a seal between the connection that you're manufacturing and the multi-unit abutment itself. So definitely you need to be at that level, and the vertical level, you need to be within 10 microns, because otherwise you will definitely not have that fit, that seal. But look, at the end of the day, the clinician will be the one that decides when that prosthesis is delivered. If there is any tension, if difficulty engaging the screw, something is not right. And I think that when you try to force it, or you're trying to kind of, in a way, just make it work, that's probably not what you are expecting of that level of accuracy. You will never feel that if we are within the range that we are talking about.
And it's interesting that you mentioned something that a lot of people don't think about, is that, yes, the data capture may be 20, 30 microns, but then if you just send it to a local lab, it really depends what milling machines they're using and the tolerances on the milling machines, because that's also a margin of error. And
yeah, absolutely.
How do you juggle all of this? Even the design, there's a margin of error, the tolerances on the milling machines, the burrs they use, the type of machine. So how does this all fit together?
Yeah, so that's actually 100% true. That's what we kind of kept the control and the process from beginning to end, because the first step is acquiring that data and guaranteeing that tool that you are using, in our case, the Scan Gauges kit, is giving you the best data possible. But then it comes to the design stage. How do you guarantee that that file that ultimately is the one that is used to design the case, and then ultimately how to guarantee that data is now the ones and more accurate that is going to hit whatever manufacturing you're doing in the machine. So what we do here, and we have developed over time, is using 5-axis milling machine, industrial milling machines, to do this milling, because we know that with using these machines, we're able to guarantee a very little discrepancy and variations from the data that we recorded to the prosthesis that we are delivering. So that was something that we embraced since the very beginning. Since the university days, we actually noticed that whatever was available, it was not up to the standard to guarantee that the data that we were recording, that we were able to get something out that was acceptable. That's something that have differentiated ourselves from many other players, offering these kind of restorations. And also, we kind of have developed our own connections just to reverse engineer the original manufacturing connections, making sure that our milling strategies match that, our design match that. So everything had been built from the ground up to guarantee that there is no variable that can affect that accuracy through the process. We did not get here over time. Like it just took us a long time. Like we started learning how to create these libraries, how to digitize these libraries before even Exocad or 3Shape were actually doing it themselves. We were already creating these libraries and making sure that whatever we were able to design, it was able to be manufactured 100%. Creating form tools that are unique to each connection, just to guarantee that you have that level of expertise and you can deliver quality to your clients. How do you differentiate yourself from many other billing centers around? How you present a proposition that is going to set you apart? That was what we were aiming.
Do you guys disclose what milling machines you use?
No.
I tried. Okay, so speaking about the data, you mentioned 20 to 30 microns on your systems, and a lot of systems now with the horizontal scan bodies say similar. What is traditional photogrammetry getting?
Yeah, I think that it really, now that obviously we are at this stage within this world of digital, we actually have tested internally different photogrammetry systems. We have seen a variation depending on the photogrammetry system. Obviously, I'm not going to go into the details, but we can see that there's photogrammetry systems that can get that accuracy consistently. And there are some others that, over time you need to replace the flags because you start seeing the drop on accuracy over time, that the arrangement of the photogrammetry system needs to see certain way to get probably the best possible angle to get the best data available. And there is some others that obviously probably they have not been manufactured, the standards of other systems out there that give you kind of an outcome, but not probably the best outcome. So it's same as there's horizontal flags, there is a range and there is different levels of quality, us and a few other, the rest out there. With photogrammetry is the same. You have some manufacturers that definitely have embraced and improved their systems and the process and delivered consistent results, but there are some others that definitely they're not probably as consistent. We see a big variation on the acquisition. And one thing obviously is acquiring that data on the bench. Very different thing is actually applying these systems in the mouth. And that's kind of the ultimate test. Like, can you acquire the data in the mouth? Is it easy for me to acquire the data? Can I transfer that and be able to start or get a partner at a lab that can take that technology and using the best technology, the best advanced manufacturing techniques, deliver a final restoration? There's a big, journey, and you need a partner that be able to maintain that and deliver quality for sure.
It's funny how just because it's photogrammetry, though, a lot of people just assume, oh, that's the gold standard, it's the most accurate, and when in reality, a lot of the times it's not. Some of these photogrammetry systems, especially on the economic side, are actually not very good.
Yeah. And look, that's what in my eyes, Osteon Medical have always been out there and clear about what we are able to achieve and everything. We never actually put a competitor down, or, we never speak ill of anyone that's trying to achieve or do things or start new ideas. We were there at some point and we got a lot of heat. So we don't want to do that against other people. Every system have their pros and cons, and every clinician have a team or a structure or a system that is more suitable to their everyday work. There is clinics that normally do one full arch every 2 months. There is companies that do a lot. Basically, that's their objective, do full arches, and they do it really well. So how can we assist them to be more efficient? And also, how can we guarantee that this is all about consistency, making sure that over and over and over, every single case, you deliver results. So yeah, that was our aim since the beginning.
Pretty inspirational, man. Look, from being one of the first in the industry to do this, and now it's everywhere. I guess if you reflect and look back, what are some of the things you guys would have done differently if you could?
Yeah, probably would be better at presenting remotely just to be able to deal with that challenge at the beginning of COVID. We would have been able to reach more people and be in many, many places a lot easier. We had to learn on the flight just to be able to convince people through a screen that this was possible. That definitely was something that we were not expecting, but no one was. That's probably a challenge there. And growing is always a challenge as well. As I mentioned, we were a startup, and developing technology and then finding and being able to build this and structuring the whole infrastructure that is necessary for this to be successful is a challenge. We followed Michael's lead, and I think that we did the best we could with the resources that we had at the moment. But yeah, always retrospectively how things could worked out a little bit different, or how I would have done certain things in different ways. But I think that having the right people and being able to build these teams and having the opportunity to keep developing and keep embracing new things, it kind of gave us a chance of being relevant in the market. We have faced moments where there was technology that had been launched and it had been challenging to deal with it. So we need to adapt, we need to keep moving forward, and technology is going to just keep changing and keep evolving. And that's probably what we had always embraced, not being afraid of the change and be able to move forward with it.
Because it's changing a lot, especially recently. I mean, it's been crazy, the level of change, especially in the past 12 months in the full large game. I
Yeah.
guess my follow-up to that would be, being first in anything is incredibly challenging. What are some of the things you've learned, okay, kind of being the first one to bring this to dentistry?
I think that you learn the level of pushback that you're going to get, and the ability you have to develop to have to convince people that the idea that you have put forward actually is something based in reality. There's a lot of noise out there, and now with social media and things like that, and fancy AI, you are able to try to get a good message out there. But if it's not based on reality, at the end of the day, any user is going to see through the curtain and you're going to see that it's not something real. That communication of new ideas, that getting to convince people and being honest to the people that we face when we're trying to present these new concepts or new strategies, just to make sure that when we are able to be clear about the aim and how we wanted to make sure that it's an improvement on whatever system they have been used to it, I think that people can see through it. And it took us a while to probably get good at that. But at some point, we were able to get the rhythm and get that message across. I think that that's a big learning for sure.
And look, it must have been a challenging past year for Osteon Medical. I mean, you guys still have the milling center, so that's a big part of the business. But in terms of the pushback from all these other companies now that are doing the same thing, I guess what's next? What's next for you guys? I mean, one reason I never used your system is because I have an in-house lab. I used it a couple of times at work. The workflow is super nice, and you guys produce incredible prosthetics. But being someone who has an in-house lab, I needed a system that allows me to use my lab. Are you guys going to consider opening up in the face of all this kind of competition, or
Yeah.
what's next for the company?
No, absolutely. That's basically the next step. I think that opening the system was always on the cards and it was the right next move. We didn't want to just create a platform that give you outputs and that the labs can use independently. We wanted to build a platform that actually labs can use to have a partner. So we have developed Nexus Connect. Nexus Connect is the version for labs to be able to use Nexus iOS, use the kit, and being able to kind of take the technology, deal with and acquire data, and be able to take advantage of the accuracy that our systems can deliver. So Nexus Connect is a full-blown platform that allows you to have an inbox to manage your case, to be able to get data directly from the patient, from the doctor, running the whole system in the cloud. It gives you access to the Nexus Analyzer, and it gives you control to the lab about his kit. They own the kit, and there's no input from us whatsoever. They have now complete access and complete control, and you have a milling partner right next to it, because if at any point you want to do some milling with us, the quality of our milling and what we're able to achieve, they can use us. They can use our design services as well to this platform, but they can grab the data and use it as any lab will normally do. So we have already kind of do a soft launch and have some partnership with the labs in the US and Australia, and it's going really well, and it's going to keep evolving. The platform is now out there for any lab that wants to embrace the scan gauges system and introduce it within their own system. It's ready to go.
Dude, it sounds fascinating, man, and super interesting that you're creating a platform around this and also tying in your milling center. I am curious though, and with full respect, do you ever wish you released this earlier, like a year earlier? I mean, what is this reactionary, or was this in process for a while? Because I feel like you guys just had the kit. You had the kit, you had the system, you had everything. You had a great team, the milling center. But if it was just released a year ago, I think this would have captured a lot of attention compared to all the other kits that are doing it.
Yeah. Look, I think that there's a lot of lessons always, and retrospectively, as I said before, you would have done things certain way. I think that our software team worked on this really hard just to try to get it to a level that it was kind of acceptable and it didn't compromise the quality and it was good enough. Sometimes it's hard to get these things done as fast as you want it, but I think that at the end we got there. And yeah, definitely, as we mentioned, I probably mentioned at the beginning, the fact that sometimes technology cross with a good idea and you're able to take it forward faster. Maybe this way, this particular one was a slight delayed where it should have done. But look, we got a great team and we'll keep working at it just to try to make sure that we present a proper alternative to what everyone is doing. Like that's probably what we want to always embrace, to trying to offer options and evolve and adapt depending of what is happening in the market. And we'll see obviously the outcome of the software, and we obviously will keep working and kind of following how the DNA of the company of embracing innovation will definitely integrate not just technology in acquisition, but technology in materials, technology in manufacturing processes that have set us apart. And that's probably what we will continue doing.
Well, my friend, I wish you all the best and all the success in the coming years. I'm sure they're always challenging years, but the market seems to be heating up more and more. Thank you so much, Julio, for joining me.
No, Ahmad, thank you very much for the opportunity. Really appreciate it. We're big followers here and always happy to talk honestly about the industry and where is it going.
And you guys have done a remarkable job, and you should be proud of the journey, because literally you did this first, and that means a lot. So well done, and thank you again for your time and your expertise and sharing this with our listeners. Guys, that has been Julio Rojas, the Director of Product Development at Osteon Medical. Thank you so much again, Julio. And for everyone listening, please like, follow, share. Thank you for listening to this episode of the Digital Dentistry Decoded podcast, and I will see you in the next episode. Thanks for listening.